Welcome to the XFO Intelligence Podcast. In the relentless pursuit of artificial intelligence, we've been operating under what seemed like an iron law. More scale equals more intelligence. The race has been measured in parameters, millions, billions, and now trillions. And with each order of magnitude, it requires exponentially more computational resources, more energy, and more capital. This scaling paradigm, it created an inevitable consolidation. Only the best resourced organizations could really compete at the frontier. That era is ending. Samsung's Tiny Recursive Model, or TRM, it represents what physicists would call a phase transition. It's not just an incremental improvement, it's a fundamental rewriting of the rules. Think about it. A 7 million parameter model that competes with systems 10,000 times larger on reasoning benchmarks. Wow, that isn't just better engineering. It's a totally different approach to intelligence itself. TRM's innovation, it lies in how it thinks, not how big it is. So where traditional large language models, they generate answers through a single pass prediction, TRM engages in a recursive self-dialogue. Here's how it works. First, the model produces an initial draft, a first attempt at an answer. Then, and this is the key part, it moves into a latent critique, building an internal scratch pad to examine its own reasoning. Following this, it enters a phase of iterative refinement. Through up to 16 cycles, it critiques and improves its own logic. And finally, the process continues until the reasoning stabilizes, and then it produces a convergent output. This approach, it mirrors how we as humans tackle complex problems, right? We rarely get things right on the first try. We think, we reconsider, we spot flaws, and we refine. TRM, it institutionalizes this very process at the architectural level. The results are, frankly, staggering. Competitive performance on the demanding ARC-AGI benchmarks with a model small enough to run on a smartphone. Wow, that isn't just better engineering. It's a totally different approach to intelligence itself. The most immediate impact is, it's economic. Training and running trillion-parameter models requires computational resources that concentrate power in the hands of a few tech giants. TRM's efficiency, it just changes the fundamental business calculus. Take training costs, for example. Where current frontier models require data center scale resources, costing tens to hundreds of millions of dollars, TRM class models can be trained with orders of magnitude less compute. The operational cost of serving AI predictions, it drops from significant per-query expenses to essentially negligible. This enables business models that were previously just impossible because of their cost structure. And with deployment flexibility, these models can run on-device. That eliminates cloud dependency and enables applications where latency or privacy or connectivity are paramount. Our analysis reveals that the AI market is approaching an inflection point, a lot like the transition from mainframes to personal computers. The centralized model is giving way to distributed intelligence. So, as the cost of intelligence plummets, the AI competitive landscape it'll fragment and reconstitute along new lines. Through some sophisticated modeling of this emerging ecosystem, we can identify several predictable phases. Phase 1, which we're seeing happening between 2025 and 2026, is what we're calling distributed exploration. The low barrier to entry will trigger just an explosion of experimentation. Startups and research groups will test recursive architectures in healthcare diagnostics, legal analysis, scientific research, edge applications, you name it. The key insight here is that a diversity of approaches will yield more innovation than concentrated resources ever could. Then comes Phase 2, from 2026 to 2027, vertical specialization. Success patterns will start to emerge in specific domains. So instead of a general-purpose AI, we'll see highly optimized recursive models for particular applications. Think medical diagnosis systems that reason through symptoms, or legal AI that recursively analyzes case law, engineering tools that iteratively refine designs. Phase 3, beginning in 2027 and beyond, is all about network effects. The most successful recursive models will create these powerful ecosystem advantages. Interoperability between specialized systems will create compound value. Talent will cluster around the winning architectures, and the basis of competition will shift from scale to network positioning. So what about the competitive moats? Incumbent AI giants, they built their defensibility around computational resources, data accumulation, distribution channels, that sort of thing. The TRM revolution creates entirely different sources of competitive advantage. These new moats will be built on architectural expertise, domain-specific optimization, ecosystem positioning, and a new kind of talent. Talent with systems thinking, the ability to reason about emergent behavior and recursive processes. Our modeling identifies a critical threshold here. When approximately 15% of top AI talent migrates to recursive architectures, the ecosystem becomes self-sustaining and resistant to incumbent counter-strategies. Of course, this revolution will also create second-order effects that ripple well beyond the technology industry. A transformation in privacy, for one. With models running entirely on device, the fundamental privacy trade-offs of cloud AI, they just disappear. Your sensitive data never has to leave your control. We'll also see a geographic redistribution of innovation. When computational resources cease to be the primary constraint, innovation can flourish outside of the traditional tech hubs. New regulatory challenges will emerge as governments grapple with AI systems that run locally and don't transmit data. And maybe most importantly, we'll see greater economic accessibility as developing nations and smaller organizations can finally compete in AI development without needing that massive capital investment. For entrepreneurs and investors, this creates specific opportunities in, vertical AI startups, developer tools, interoperability platforms. For incumbents, the threat is existential. Companies overly invested in the scale paradigm, they face disruption from more agile, focused competitors. Looking toward 2026 and beyond, we predict a landscape where specialized dominance trumps general-purpose providers. Successful incumbents will be the ones who blend scale-based and recursive approaches. And the most creative AI researchers will migrate to environments where they can focus on architectural innovation rather than just scaling existing approaches. The fundamental shift is from intelligence as a resource to intelligence as a process. We're moving from building ever larger statistical models to designing ever smarter reasoning systems. The companies that thrive in this new landscape, they won't be those with the most compute, but those with the most creative architectures. The next decade of AI will be defined not by how big we can build, but by how wisely we can think about thinking itself. Now, here's a question we'd like you to think about. As intelligence moves from massive data centers into our own devices, becoming a process rather than a resource, what's the first complex problem you would want your personal, private AI to solve for you?